Piaget's conservation and class inclusion tasks illustrate variations in children's cognition from early to middle childhood and highlight for Piaget the distinction between pre-operational and concrete operational thinking. Conservation refers to the idea that certain physical characteristics of objects remain the same, even when their outward appearance changes. Let's watch Allison, age 4, try Piaget's conservation of liquid task.
Do they each have just the same amount of water, or does one have more?
I don't think any has more.
Oh, now it looks like they each have just the same amount of water in them, all right? So now let's watch and see what's going to happen. Shall we take the dish, and we'll take this water and we'll pour it in the dish, all right? There it goes, in the big dish, big wide dish, like that. And now, is there just as much water in the dish as there is in the glass?
No.
Or does one have more?
This has more.
And how come?
Because I don't know.
Oh, hard to tell, huh? What makes you think it might have more?
Because this glass is bigger than the bowl.
Oh, because this one is bigger than the bowl. I see, I see. Now, let's see. Do you think I can pour that water back again without spilling it?
Yeah.
Let's see if I can do it. Oh, I have to try hard here to do that. And see if I can get the water back in the glass. And there, we did that. And now, is there the same amount of water in each glass, or does one have more?
I think they both have the same.
You think they both have the same now? I see about that.
Like Allison, 4.5-year-old Stephen finds conservation of liquid challenging.
Is there just as much water in the glass as in the dish?
No.
Does one have more?
This one.
Oh, this one has more.
In this conservation of number task, Allison centers on the new arrangement of the chips, overlooking the fact that the quantity of chips has not changed.
Which would you like, the white chips or the red chips?
The red.
The red chips. And then will you count them up for me? Okay, let's see.
1, 2, 3, 4, 5, 6, 7, 8.
8. Oh, 8 red chips. Now, how about my chips? Are you going to help me count my chips, and we'll put them out next to the red chips? Okay.
1, 2, 3, 4, 5, 6, 7, 8.
Oh, how about that? So we each have a line of chips, and I have the white chips, and you have the red chips, right?
Yeah.
And are there just as many red chips as white chips, or does one row have more chips?
None has more chips.
None has more chips, and that means there are just as many in the red row as there are in the white row. Hmm? And now, shall we take your red chips and bunch them all up? Should we do that? All right, let's bunch them all up here together. And now, are there just as many red chips as white chips, or does one have more?
This has more.
And how come?
Because this is a line and this is a circle.
Oh, because this is a line and this is a circle. I see about that. And so how can we make it the same amount?
If you line them up again.
Shall we do that? Shall we line them up again? Let's do that.
In this conservation of length task, Allison fails to mentally return to the start of the task, when the straws looked identical.
I'd like to know if we have the bear walk down this road and the little kitty walk down this road, if each animal has to walk just as far, if one has to walk farther.
They don't have to walk farther.
They don't have to walk farther. They each have to walk just as far. Each road is just as long? Okay. Now watch, I'm going to change the roads. I think I'll just move this road right there. Okay? And we'll put our little bear at the beginning of the road, and here's the little cat at the beginning of this road. And now I'd like to know, does each animal have to walk just as far down the roads, or does one have to walk farther?
This one has to walk farther.
And how How come?
Because you moved the road.
Because I moved the road, and so how come he has to walk farther just because I moved that road?
Because the line is... Because you moved the line.
Because I moved the line, huh? And so he has to walk farther down that road.
Victor, age 7, has no difficulty with Piaget's conservation of mass task.
And now I'd like to know, is there the same amount of Play-Doh in this pancake as in this ball, or is there more Play-Doh in the pancake or more Play-Doh in the ball?
They're still equal.
They're still equal, and how come?
Because you only took the ball and made it into a different shape. It doesn't mean you add something into it. You just changed how it looked. You didn't add anything into it. You just changed how it looked.
I see.
When a conservation of number task is simplified, younger children can succeed.
Shall we play that game one more time? Here, let's play it with 3 chips one more time, all right? Now, are there just as many white chips as red chips, or does one have more?
They don't have enough.
Oh, they don't have more. They're the same number of white chips as red chips. How many in each?
1, 2, 3. 1, 2, 3.
1, 2, 3. And now, what am I going to do? I'll bunch up these white chips, all right? And now are there just as many white chips as red chips, or does one have more?
They don't have enough.
They don't have more. Does that mean there are just as many white chips as red chips? And how come?
Because there's 3 of these and 3 of these.
Because there's 3 of these and 3 of these. I see.
Here, a conservation of mass task is made relevant to Allison's everyday experiences, and she reasons maturely, showing clear evidence of reversibility.
Have more.
All right, so just the same amount of Play-Doh in the muffins as in the ball? And how come?
Because if you bunch them up again, I'll have the same amount.
Oh, can you show me that? Show me that. If you bunch them up again, you'll have the same amount.
Class inclusion tasks assess children's understanding of hierarchical classification, the ability to organize a set of objects into one general class and at least 2 subclasses, and shift flexibly between these levels. 5-year-old Nicole has difficulty.
Are there more green balls than pink balls, or more pink balls than green balls?
More green balls than pink balls.
Yes, and they're all balls. Now tell me, are there many more balls? Are there more balls, or are there more green balls?
Green balls.
More green balls, and how come?
Because there's only 2 of these, and there's a lot of these.
And there's a lot of those.
7-year-old Zoe handles the class inclusion task easily.
Tell me, are there more green balls than pink balls, or more pink balls than green balls?
There's more green balls, and you don't even have to count them to see, because when you just look at them, you can tell there's way more, because if there was more pink balls, there'd probably be a bigger group of pink than this half of the group. So then you would know, but since there's only 2 and they're smaller, then you know that there's more green balls.
Yes, you can tell that. Now, how about this? Are there more balls, or are there more green balls?
There are more balls,
And how come?
because if you put the pink with the green and add them up, then it would be more than just the green. It would be 2 more.
Victor, age 7, clearly focuses on both the general class and the subclasses, succeeding at hierarchical classification.
It's really complicated to tell this, explain. Well, here are all the red. You know that there's more red than blues. Now, if you add these 2 together, they make a larger number than the reds. Now, this would be all the balls. But if you take away this, then if you take away the different colors, there'd be less. Now, if you add up all the colors together, there'd be more than the red, because the red is less than all